Langley proposed that drugs act through receptors, and Hill provided a mathematical framework for this. The next logical step was to quantify drug-receptor interactions. This was done by Alfred Joseph Clark. Clark studied the effect of acetylcholine on frog skeletal muscle. He measured the contractions at different doses of the drug, and the peak contraction for each dose was taken as the response. He found that the response increased with increasing concentration but plateaued beyond a certain point. This maximum was defined as 100%, and all other responses were expressed as percentages of this maximum response. Now, he couldn't fit this wide dose range onto a graph, so he plotted the responses against the logarithm of the dose. This is the dose-response curve of today. The data consistently followed this equation. With his background in physical chemistry, Clark recognized that this indicated a reversible interaction between the drug and a finite number of receptors, probably on the cell surface. This was similar to adsorption onto a finite surface as represented by Langmuir's equation. Here theta, the percentage of surface occupied by the adsorbed substance, is analogous to the percentage of receptors occupied by the drug. Now, comparing the two equations, y, the percentage of response, occupies the same position as theta, the percentage of receptors occupied by the drug. So Clark concluded that the magnitude of the response must depend on the percentage of receptors occupied by the drug. This idea became known as Clark's receptor occupancy theory.